of all, thank you so much for joining us here today over beautiful Munich. This is a wonderful location. What I'm going to tell you here today is a story that we call the Sentient Enterprise. And I have been personally working with Mohan Sahni, a professor at Kellogg School of Management in Chicago, on this concept for approximately the last 2.5 years. About then, at that time, we met and we exchanged ideas and experiences of what we have seen major companies do with data to advance capabilities and to build new business models that have not existed before. And with that, we came up with that concept of the Sentient Enterprise, which is meant to be a North Star of where companies are trying to get to. Many companies will never reach that, just like Six Sigma in quality or zero inventory in supply chain are kind of North Star goals that you work towards. And so I'm going to take you through that story. But before we do that, I'm going to give you a little bit of a frame to set up that story. Let's start with a business example here that it's all too often happening in companies around the world today. The story here is about a CFO that is just about to announce quarterly earnings for a telecommunications company. And all of a sudden, as the numbers come rolling in at the end of the quarter, the company realizes that they have a 5% revenue shortfall compared to where they thought they would get to. And the CFO is bringing together her team, the team of marketing, CMO, different executives in the company, and everybody has theories. Everybody shows up with numbers. The numbers usually don't match. And I've seen companies where numbers like how many active customers did we have in the last quarter were off by more than 50% between different executives within companies. And all of that because we typically work in an environment where we have silos of data, where we have different sources of information, and where numbers often do not match up across boundaries or across different organizations within companies. And that usually creates a real problem. There's a lot of theories going around. There's a lot of fire drills going in companies like, let's prove why our numbers are the right ones versus their numbers, right? Or let's find out what are the real numbers. And it gets very difficult. And in the end, companies often almost accept defeat and say, well, let's take the average of the two numbers, right? And I've been in board meetings where that has happened, right? So this is something that is all too often happening, and it's something that we really need to address in companies. Recently, a study that was done by the International Unit of Economies has asked some 400 executives around the world in terms of what their experiences are with data. And 57% of the respondents have said that important data in the company is not even captured, or they wouldn't know where it is captured, right? 42% of the data is either cumbersome or not user-friendly. You can't access that data without asking specialists or without making a request to somebody else, right? And in many cases, 75% of time is wasted in companies searching for the data or dealing with the data discrepancies that are happening throughout organizations. We refer to that as data drift, when a copy doesn't match up another copy of data anymore. All of that is happening while we live in a world that is evolving faster and faster. We hear concepts like exponential growth and exponential thinking. New technologies are coming to the market faster and faster. What took 30 years to adopt half a decade ago now takes 5 to 7 years to get adopted. And I'll give you some examples of what we're talking about here. It means to a lot of our companies that we have less and less time to optimize our customer relationships, our products, the quality that we develop, and product development is becoming ever so faster, right? One example is clearly is a company in California, Tesla, that started out 10 years ago, or not even 10 years ago, to become a new car manufacturer. Was almost impossible to think of that just 10 years ago. If you would have told me that a new car manufacturer can enter an already very crowded space in the industry, I would have said it's impossible, right? Now we see how far Tesla has come, and they're not only specializing on cars, they all of a sudden want to become the battery home provider for households around the world. They also, just in recent weeks, they're trying to acquire a solar energy company to really be seen as an alternative energy leading company, right? Where transportation is just one of the products out there. Again, 10 years ago, that company was just started, right? So really interesting to see how fast companies are changing and new concepts are coming. There's a couple industry trends happening out there. One of the interesting ones is real-time interaction. We live in a real-time world. I remember 15 years ago when I moved to California, my bank would send me a monthly statement of, here's your checking account and here's how much money you have in there. It would be impossible to think about that. If your bank doesn't have an app and a website where you can get the information in real time, you would probably not be doing business with them anymore. Sports scores, travel, finance, news, everything has become real time. Yet when you look at companies and IT internal, we struggle with that. A lot of things are not real-time in traditional companies. A lot of things are still done in batch, once a day, once a week, even once a month, right? And when that interacts with customers that are really enabled by real-time data around them, that creates a gap, right? And it creates problems. So real-time is one thing. The other part of that is we call it self-service everything. We live in a world where we don't want to go into a bank if we can avoid it. We prefer an ATM. In fact, we don't even want to go to the ATM anymore. We want to have an app on our phone. Who wants to call a call center and wait for 20 minutes to get in line to get something done? If I can do it myself through an app, through a website, I will always prefer that over dealing with human beings in companies, especially when companies are becoming more and more difficult to work with at scale because of problems like real-time and self-service is a big thing. So if you think about what companies are doing internally, when we think about how IT and other departments in companies work together, self-service is not one of our strengths usually. We write big requirements documents, right? And the problem starts usually right there, right? We don't know what we need from data, yet we have to write a 50, 100, 800 page document detailing exactly what we get done so that somebody else can then do it for us. And we've learned over the years that is just not fast enough, and we cannot get agile enough doing that. So we need to build self-service into the core capabilities of our companies. Another interesting trend that we see out there is the app economy. Started also about the same time, less than 10 years ago. The iPhone came out, and in fact, it took a year until Apple released the App Store. It was the first App Store that came out, and all of a sudden, a company started realizing that they themselves cannot write enough software, enough applications to satisfy our needs. So why not enable the world of developers, right, to do that? By 2017, the app economy will be a $70 billion business. From 0 to $70 billion in 10 years, right? Again, an example of how fast things are moving, but it's also an example of how companies have realized that through app platforms, less experienced people can develop simple apps. And when you look at how we do it in IT ourselves, so in companies, we usually write requirements documents and then we give it to a development team and then we hope that they develop it for us, right? We need to adopt some of these philosophies, and I'm going to tell you how we're going to do that as part of the Sentient Enterprise. And so if you were to do these things, and if you ask executive if you would make information easily and quickly accessible and shareable, it would lead to a lot more collaboration within organizations. And 57% even state that it would lead to better risk control within companies, because the data drift that is causing all these incorrect answers could be managed in a better way. So how do we do that, right? How do we go about that? And the story that I'm going to tell you today is not about technology. It's not about buy one product and implement it. And what we have learned over the years, and in my specific case, I worked for 7 years at eBay, we realized that the largest part of the success was the cultural change, the educational change, the people management, the process management. We could sometimes buy the best technologies. If we didn't manage the change control effectively, the best technology is not worth anything, right? So we really had to focus on how do we implement capabilities, and that's what the Sentient Enterprise is about. So with that, I want to quickly describe what is the Sentient Enterprise. The term came together when Mohan and I sat together in November of 2013, and we said, you know, we need companies to listen to data in real time, interact with data, learn from behaviors, change the behaviors, and do it faster and faster. And the term that we came up was the term sentient. Sentient, human beings, we are sentient. We perceive, we feel, we listen, the left hand knows what the right hand is doing. The problem is the more of us you put together in a company, the more we lose these capabilities. We get slower and slower. You know, when we tell each other something, by the time it has been retold 5 times, it sounds completely different, right? And the same happens with data in companies, right? And so the idea is, how do we create a single company that acts like a single organism, right? Where we identify opportunities, where we allow people to search and discover, analyze, create knowledge that is broader than small groups or individuals, and that really becomes the foundation of the company. And that allows us to work in a faster and faster exponential world where development is happening nowadays in months rather than in years, right? So with that, let's go into that model. We created a 5-stage model that allows us to describe what are the individual capabilities. Again, these are not technologies. And yes, you will use technologies in companies to implement them, but it's not about the technologies. It's really about the change management, and it's about what you need to do in order to get good at that. And the first stage is all about agility. We call it the Agile Data Platform. Has nothing to do with hardware, has nothing to do with software. It has to do with a capability in an organization to say, how do we become agile in companies? And let me tell you one thing. A lot of companies that I walk into today will tell me they're agile. And when I ask them, how are you agile? They said, oh, we have stopped writing documentation. We no longer do architecture. We just do things very, very quickly, and every 30 days we get output. And my response usually to them is, well, that sounds more like Wild Wild West than agile. Agile is actually something that's very difficult to implement, and it requires a lot of change management. Yes, there are methodologies like Kanban or Scrum that companies implement, but it's something that really needs to be put on a foundation that allows you to scale that out. Yes, it is a lot of training. And by the way, we ourselves at Teradata are going through this transformation right now. We used to build software in 18 months increment. We are halfway through our transformation to go into agile development, and by next year, we will deliver products every 4 months, software releases every 4 months. It's a complete change of how we think and how we operate. And by the way, you can't forget about quality. And you need to make sure that what you build in smaller, faster increment works and is sustainable, right? Because a year down the road, when you're not careful about agility, you sometimes build a card house, and then you pull one of the cards out, and then the whole card house comes crushing down. So agility. First stage is all about agility, and I want to give you a couple of examples here, specifically around data, what we do in order to make us agile. In many organizations, we have sort of centralized systems somewhere that produce data, whether it's supply chain, whether it is ERP, whether it is customer service, CRM systems, marketing tools, financial tools, everything, right? There are systems that produce data, and then we have this need for, let's do something fast. The CMO needs to find out how to run a new campaign, or as we've just heard from one of our customers in the United States, when the iPhone 6 came out, all the wireless providers in the United States got a 3 months notice that they are basically losing their SMS business because it's now all iMessage. And so they had to react very quickly, right, to something that's a completely new business model for them. How do you do that? Well, in many organizations, it takes 18 months or longer to implement new capabilities Because we start with that requirements document, right? We write down what do we need exactly, and in many cases we don't know it. Therefore we say, give us all data in all possible combinations and let us run drill downs on everything, build us a dashboard with every KPI possible, and by the time a team sizes this up, it's a year or 2 or 3 to develop that, right? And it's something that more and more business units say, oh, we can't wait for that, right? That takes too long. So what do? Well, they just come to their technical teams and say, well, just give me access to the data, right? Let me take a copy of that data and I'll stick it into a sandbox. And obviously the cloud enables us to do things a lot easier, right? With cloud, I can spin up new test cases very easily and I make a copy there. And the problem is when I do that, I immediately start creating a problem that we call a data drift. Whenever you copy data somewhere else, whether it's on the cloud or on premise, that data is out of date the moment you're done copying it, right? And we usually, because we want to be agile, we don't deal with how do we keep this in sync? How do we keep this updated, right? And therefore, data drift becomes bigger and bigger. We measured that ourselves when I was back in eBay, and we found that more than 60% of data that was out there in copies was out of date. So much so that when we looked at our CRM data mart that we had back then, that around 2005, was controlling the vast majority of our marketing spend. When we did a deep analysis, we found that the customer table was 60% out of sync with the real customers that we had. We would send coupons and promotions to VIP customers who no longer were customers. Or we wouldn't have the latest VIP customers even there, right? And we were directing marketing spend with this capability, a real problem. Not only does it happen once this happens, it usually happens all over the place within companies. And we are creating tens or dozens or hundreds of copies of data that all of a sudden start running out of sync, right? And again, on our quest to agility, that often becomes the first implementation. Give me data, let me make a copy. I'm going to run Scrum on this. In 30 days, I have a result. The problem is it's not sustainable and it's usually leading to incorrect results all over the place. So as we're going into this agile world, we found that we have to really plan for this. Obviously, there's a business need to do something with data very quickly. Obviously, we have to change and go away from the traditional waterfall methodology that starts out with describe the problem, then develop, then test, then roll it out. We need to do something that we can do incrementally, but we cannot do it with these silos of data. So what we started doing, and that was around 2005 back at eBay, we said, how can we plan for efficient sandboxes and introduce a level of self-service that anybody can commission a sandbox without having to copy data around, right? And we created this concept of a data lab where we said all data in the organization that we have integrated must automatically be available in this data lab, but it should also allow me to store incremental data, right? And oh, by the way, the first time you talk to your operations team and say, oh, by the way, I'm going to create these data labs on top of production systems, and it basically means that marketing will create their own data structures on top of a production system. That's a big culture shock, right? At first, it's like, over our dead bodies, nobody can touch a production system, right? So intermixing the concept of agility in production is the first thing that you need to manage within a company. And so we built this sandbox concept, and quickly throughout the company, this sandbox concept started to take hold. In fact, if you nowadays go into eBay, you will probably find around 1,500 active sandboxes where different teams around the globe in different countries take subsets of data and experiment with that and try to find new insights. And by the way, we had to time box these things, right? So in order to stay and implement governance around that, we had to say, well, you can have a sandbox, but you can have it for 30, 60, or 90 days. And by the way, if you're not using it after that time, we're going to get rid of it, right? We also realized that we had to record everything that's going on in a sandbox. So for every request, every query, every model, every analysis that's going on there, we have to record what people are doing with that. It's a critical capability that most companies don't realize how important that is when you do agile, when you do self-service within a company. Just like you need to listen to your clickstream data or to your connected car data, you also need to listen to all of these requests in these sandboxes so that at any given point in time, you can go back in time and say, this is what we did, let me hit the replay button. Or now I want to move that in production. What do I need to do? What has been used? In fact, we built a capability where we really built out the concept of analytics on analytics, where we analyzed all the behaviors of all business units within the company to understand what people are doing with the data. Critical capability. So agile coupled with self-service, coupled with governance, and advanced analytics to understand what everybody is doing became the foundation of agility for us as a company. Now, as we built that, we also realized that we need a different way to integrate data. This whole concept of waterfall, again, we start with requirements document, then we create a data model, then we ETL the data, then we build BI on top of that. That had to be broken down. And we realized that there's too much data all of a sudden happening that we cannot model everything up front. We don't even know what we will have to model because we don't even know what data we will be using. And oh, by the way, more and more data comes in as semi-structured data or as highly frequently changing data. So it cannot be that we all the time have to define the data models and the structures of everything. So what we came up is this concept of the layered data architecture, where we started at layer 0, where we said, this is where we bring in raw data. And the responsibility of layer 0 is to give us lineage. Where did that data come from? And when did we get it? And how did it look like exactly when we get it from where it was, right? Keep the structure, keep the lineage, and then from there, pick individual pieces and move it up those layers into the integration layer, the calculation layer, where we then calculate models and KPIs, all the way up to the presentation layer, where we present it to the rest of the company for use and for consumption. And usually the higher up you go, the less data gets exposed to more and more people. Having said that, that layered data architecture also allowed us to really say some users in the company, call them data scientists, call them advanced users, they need to be able to go down all the way to the raw layer. Advanced users might go just down to the integration layer. Business analysts usually on top of the calculation layer. And the vast majority of users, they just get to see the presentation layer. And this is where most of our applications will then be integrated. And then all the way on top of that, the concept of sandboxes, where anybody within the company should be able to create a new sandbox. And we had an internal rule where we said up to 250 gigabytes, we don't even ask. You can have the sandbox, no questions required. When we saw larger requests, we would then say, okay, you need to have a director or a VP approve that request. And with that, we built that layered data architecture as a capability to help us implement agile with data, with sandboxes, and to break down the requirements of the organization and break away from traditional, everything has to be modeled, everything has to be ETL'd, into a repeatable structure that can grow over time. When you look how we use that, you can also see that at the very bottom layer, we use concepts like tightly coupled, loosely coupled, and non-coupled data. Tightly coupled data comes, for example, out of an ERP system. We know exactly how every transaction interacts with every account, with every customer. But then the more you go into clickstream data or sensor data, you sometimes get data that is not related to your company at all, right? If you look at weather data, for example, right? But that raw data can later on, through models, get integrated with your company's data through geolocation, through point in time, through various dimensions, right? And the higher up you go in that layered architecture, the more you can integrate that data, right? And so it really became kind of our backbone of how we designed projects and how we implement data within the organization. It also allowed us to identify new data sources and within a single day bring in that new data into our systems. Because layer 0, the raw data layer, didn't require any sort of data modeling. We brought in the raw data, right? And it really allowed us to come up with an idea, with a concept, and then iterate very quickly on top of it. And we came to the conclusion that You know, when we tried to make everything work always, every project had to be successful, we started to realize and then we're trying too hard. Sometimes it's good enough to bring 70%, 80% success rate into it. In fact, we set ourselves goals where we said, if you're right more than 70% of time, you're probably not trying hard enough to break out of the existing box, the existing thinking. So first stage was all about agility. And I could go on to talk for days about agility. Obviously, agility is anchored by concepts like Scrum, but it needs concepts like self-service, and it needs to have concepts like built-in governance, like this analytics on analytics, so that you can understand what people are doing with that agility, so that when you have to productize it, you have the ability to do that quickly. Now, stage 2 is an interesting one. Here's where we talk about behaviors. We call it the behavioral data platform. Again, has nothing to do with hardware or software. It's really how companies think. And a lot of companies today still think in transactional terms. How many products did we sell last Monday compared to prior Monday, last month, last quarter, last year? And we've gotten really good at that. We probably have BI dashboards that tell us, you know, plus 0.5%, minus 2%, and we have it broken down by geography, by product category, by country, by whatnot, right? It's, however, a world that is changing where, when I look back at my own career, in the mid-2000s, our CEO back at eBay decided, you know what, revenue and profit, who were the number 1 and number 2 KPIs for the company, all of a sudden got displaced by Net Promoter Score becoming the most important KPI for the company. And whether it's Net Promoter Score or anything else, it all of a sudden became about customer behavior. We were really good optimizing profits on revenue. So good that our customers didn't really like that or care much about it. And they would leave us because they felt like we were charging them too much. And when they had a problem, we didn't help them, right? And so behavioral thinking is all about switching from that transactional thinking where, yes, we look at certain key elements within our data and we are very focused on transactions. All of a sudden, companies are looking at all the patterns in between transactions and then some, right? Clickstream data, sensor data, customer behavior data, right? And depending on the industry that you work in, it's either human behaviors or it's machine behaviors. And I'm going to give you some examples here. But that in itself, again, without talking about technologies here, where you store it or how you go about it, it's an inherent change to a company that you need to manage. Because people that are good in understanding transactional data usually struggle with behavioral data at first, because you can't count behaviors as easy. You need to identify them first. You need to build models that identify or cluster these behaviors. And you need concepts like experimentation platforms that now allow you to look at behaviors over customers over time and see how you can influence them. And in a typical banking example, it becomes clear that behaviors are a multi-channel problem. And any company that is working on concepts like omnichannel is realizing this is quite a difficult problem to solve, because I'm not just looking at fees that I'm charging and reporting on the number of fees or the amount that we have charged. We want to stitch together a fee led to a call center call, led to a web session where somebody looks up the policies, potentially a declined transaction, to a complaint being filed, to account being closed. A typical churn problem, there's a multi-channel problem that's all of a sudden requires different thinking, right? We all of a sudden have to put the machine or the human being into the center of our analysis and look over time what happened to that one human being. And how many others of customers did we have that had a similar experience, right? Think about your products and how customers interact with them and how many possible ways they have to interact with yourself. Now, machines, it's very similar. In this case, sensor data from a wind park gives us a lot of insights how these machines operate at scale and how they operate differently in different geographic locations around the world. And all of a sudden, we need to look at the sensor data and integrate that together with transactional data, together with service records, development records, when something was manufactured, but also how the weather patterns have shifted in the last 12 months and what that did to the behaviors of the systems. These are typical examples of companies shifting their mindset from traditional transaction-focused businesses. I'm a company that bids on an RFP for selling trains. Now all of a sudden I find myself, I'm a company that bids for, I have to transport 10 million customers at an availability of 99.9%. When these business models start changing, so is the thinking around data within companies, right? Transactional to behavioral, a big thing. Now, when you put this together in an organization, and we started saying, we're going to build an agile core in the company, and we build capabilities where any part in the company can bring their data together, can look at that data in a very agile fashion, and you bring in this agile thinking, a lot of agile behavioral models start being created. In fact, when I look back in my own history, we went from zero, from almost crawling to running within a matter of 2 years. In 2 years, we had created so many behavioral models that all of a sudden we couldn't tell anymore who had created what model in what department. And not only did we have to deal with the data silos or the copies of data, all of a sudden we had copies of behavioral models. And it became very difficult for us to scale the human element into this. And that led us to think about what do we need to do next? Because big data is not really a problem of large data volumes. You can buy systems that can handle tens of trillions of records or tens of petabytes, even hundreds of petabytes of information. It's can your organization absorb that? Can organizations really deal with that and implement changes that change the inherent business model within a company? And so in order to address that, that leads us right into the next stage of the Sentient Enterprise. And we call it the collaborative ideation platform. It's a mouthful, it's a heavy term. It's really about how do you bring concepts like social collaboration, gamification, together within an organization around data. How can we enable anybody in the company to contribute to that know-how of the company, to the knowledge that is not all of a sudden limited to individual groups, because typical concepts like metadata just don't work anymore. I would argue they have never worked for us at scale, really. But so what can we do in order to collaborate better and describe what we're doing? And back in 2009 or so, we came up with this concept. We had to build something where we said, we need to build a capability, and we call it the data hub. We said, we need a capability that is almost like the LinkedIn for analytics, where we can follow analysts, where we can follow even data sets and visualizations, where we can see what is trending within a company, where people could exchange ideas, search for information, find information based on smart search indexes, based on what the rest of the company is doing. And again, we took this concept of analytics on analytics to an entire new level. We put a web front end in front of it and said, how can we follow data? How can we like insights? What can we do with that? We also built capabilities like query suggestions, where newly hired people that wanted to use data were pointed against data sets that other people in the organization are using. And we started doing merchandising of data, where we, for example, we said, oh, people that use that data set usually combine it with that data set, and they do it in the following way, to really enable sharing of knowledge across the organization. Typical problems like Q&A forums for collaboration, right? To really bring in an aspect of how can people help each other within the organization, and how can we learn through the analytics about what people are doing with data in the organization. All the way to storytelling, where we said, typically, results of analytics are being put and copy and pasted into PowerPoint slides or into emails. How can we give people a platform to do that and promote their insights throughout the organization and help others understand what they're doing with the data and learn from that, right? And really start creating a flow of information and knowledge where people could comment and argue and like and follow data sets throughout an organization. And that was something very difficult to implement, quite honestly. And it's something that I see a lot of companies struggling with, right? Luckily, there's now companies that offer these capabilities that you can implement, but it's all about the change management again. Because in many companies, you will see that data is also seen as a valued if I have access to data that I don't give access to somebody else, I might be valued more in an organization, right? And breaking down these barriers for organizations is really a difficult problem to solve for. But this is exactly what we're doing with the collaboration platform. And it's all about bringing the human element into this concept of agility at the core, behavioral thinking as a company, and now combining human beings, new data scientists, for example, that join the company, and give them access through collaboration to all the data assets within a company. And the faster and faster a company starts moving in this space, this becomes more and more important, because writing down or having a dedicated team writing down concepts like metadata or documentation and description doesn't scale as fast anymore, right, within that. And it's something that we see a lot of companies right now adopt. In fact, a lot of our customers are really adopting collaboration approaches to get to democratize data within the companies and make more people successful within their companies. As long as you build insights, as long as you find new insights in data, create new visualizations, as long as they are not productized within companies, it's art. It's like sometimes I walk into companies and I see these beautiful graphs on their walls, and then when I walk up to them and say, so what have you changed in your business processes? And people say, well, you're still thinking about that. It's like, well, that's very expensive art, right? Because usually it's done on very expensive systems. And if you don't change the business outcome, that's not worth it. So what do we need to change within a company to allow us to implement the insights that we find in data and really do something at scale with that? Because we cannot afford to hire just data scientists in a company. In fact, most companies will have less than 0.1% data scientists compared to the overall population of a company. That means their insights need to be shared across a lot of other people, and it can't always be a centralized IT team that now builds a very long, big project out of this. And this is where the app economy comes into play here. This is what we need to do to learn from app economies in the world, what they have done to enable developers of lesser experience to deploy on their platforms. And the example that I sometimes use is, I think in 2012, a young high schooler in the United States, his name Robert Ney, wrote in less than 30 days a game for the iPhone called Bubble Ball. I think he started around Thanksgiving in November, and by Christmas it was in the App Store. On the very first day, he got to 400,000 downloads on that game, and he pushed Angry Birds to the number 2 spot at that point in time. Angry Birds, backed by a multi-million-dollar company with hundreds of employees, displaced by a high schooler that doesn't even understand how the sensors or the memory or the display in that device really works. But a platform has allowed that person to really build something very quickly on top of that, right? We need to think about what that means in our environment, in our companies, because it's that type of thinking that we need to implement to let more people deploy repeatable results, repeatable actions in a company. And what we're talking about is really bringing all the learnings from cloud, from DevOps, from automation, from platforms together and package it up in a way where not only the experts, but any person within a company that has rudimental programming skills, whether they're in Python or in R or the typical languages that college students grow up around the world, that they can put this to good use and do something with that against the data sets, against the analysis, the models that they have built, and make it repeatable. And if we look at some of our examples, a big bank in the US is deploying apps by their data scientists, for example, and make them accessible to thousands of users within the bank to help them all leverage these insights for the particular business needs of their customers. And the idea here is really, how can we build an app framework within a company that allows somebody that is not the expert to take a few lines of SQL, a few lines of R or Python or Java code, and really build a workflow around that that can be deployed in production. Obviously, these people are not IT experts. They don't deal with version control, with DevOps, with repeatability. We have to do that. The platform has to do that for them, right? And so to make that all accessible, we need to build platforms that allow us to have more and more people within an organization take simple concepts, build visualizations, build outcomes, and insert them into the workflows of the company to really drive outcome. And once you build this environment, and by the way, you can start very easily. The first time I've overseen a team do that, we built the core of an application platform in as little as 2 months. We had the first couple of applications up and running in 90 days. And we built all of a sudden applications rather than ETL processes or data models. And it was applications that we now shared with the rest of the company that allowed us to really scale out the insight. When you build this platform, it allows you basically to engage so many more developers, just like app platforms on Facebook or on the iPhone allow, within your organization to really start implementing new capabilities, whether it is solutions for communication compliance, whether it is about sensor data, whether it is data about an oil field and how to predict if an oil drill is about to break, right? These things, once they are discovered, once the model are built, you want to make them available to as many people in the company as possible. There's a second side to this app platform that I want to talk here a little bit, because traditionally we said the integration of data always happens with somebody writes down the requirements, then somebody writes a data model, and somebody does ETL code, and ultimately we build some BI on top of that. That doesn't really work. It doesn't work for behavioral data. It doesn't work for semi-structured data. It doesn't work at scale as good as it wants. However, it's the default model in most companies. And whether it is on new technology stacks like Hadoop or traditional technology stacks like the data warehouse, we usually have dedicated teams that are responsible for collecting data, putting it somewhere, integrating the data, and do something with it. And we started to learn over the years that even that concept scales only so far. We need to give people an ability to integrate data in different ways. And we came up with this concept of a data listening platform, where we said, you know what, we need to build a self-service capability again, where anybody within the company can register a new form of data and work with typical web scale APIs, API keys to let people integrate data in real time, in batch, in mini batch, in whatever form that is needed for that, but so that it is not about an integration tool that needs to be run by 5 or 10 or 15 people within an organization, but that any development team within the organization can point data at that listening platform and say, listen to this data, this comes out of my automation platform, this is sensor data, this is web data, this is heartbeat data, this is transactional data, and then just let individuals decide, what do we want to do with that data? Do we want to store it somewhere? Okay, how about we write that into Hadoop? Or how about we write it into Teradata? Oh, how about it's in the cloud or on-premise? That should all then just be directing these data flows and to say, now I want to enable new sandboxes, new app development, and let people integrate the data from the outside in. Obviously, you need to deal with governance. You need to deal with self-service, with repeatability, right? And you need the right platform for this. But it allows you basically to say, anybody in the company can point data at that listening capability. And when I first gave that presentation, or an earlier version of that presentation, we had some executives from a very large entertainment company in the United States. They said, very interesting, we just built a data listening platform. We even called it like that because we rolled out a new capability to our theme parks where we have these wristbands that we give out to kids and to their families to allow people to integrate data from the outside in, because people could walk with their wristbands into the hotel rooms, They could walk into our theme parks. They could buy merchandise. And oh, by the way, if they lost their children, we could even find the children for them where they are. And we let them pre-plan the whole day so that they wouldn't have to wait at any one of the rides for more than 15 minutes, right? And because we were touching so many systems, we couldn't possibly write the ETL into every single one of these systems, and we turned it upside down. We built a listener for this data, and we told all the teams of all the other platforms, here's the API, and when you see one of our wristbands, this is what you need to send us, right? So it's integration from the outside in rather than from the inside out. A really important capability, and we see a lot more of next generation companies and business models built around this type of a capability. And oh, by the way, in most cases, this is real time, or at least near real time, because every individual transaction or individual behavior or sensor reading is being streamed in like that at scale within these companies. And so what that looks like is basically yet another self-service platform that allows individual development teams within a company to register their streams of data and say, let me send them into the listener, use very simple terms like web scale, APIs, RESTful thinking, or standard adapters, right, to point data into this listening environment, and then just say, within the ecosystem of data, and I have different technologies, where do I want to persist that data, right? Or what do I want to do? What of that data do I want to have processed in real time? Or what of that data I just want to accumulate so that I can analyze it after the fact, right? And it's a capability that we see a lot more companies building just over the last 2 to 3 years. This has really taken off in terms of adoption of advanced companies, which really leads us to the final stage here. And I want to spend some time on that because, quite honestly, 2.5 years ago, when we started talking about that, I was aware of maybe 3, maybe 5 companies around the world that really started thinking about autonomous decisioning, taking algorithms to the next level, not just to implement a churn algorithm or to implement a particular algorithm to predict parts failure, for example. But all of a sudden we saw companies that would use algorithms at scale to monitor all of the company's data and do some very interesting things. Because we saw that companies that had hundreds of analysts would all of a sudden deal with so much data, so many KPIs, so many drill downs, that they didn't have physically enough human eyes on all of the data to look at every data set every day. And when you start looking at a data set, usually things start drifting away on you or start going wrong, right? And so there's companies that nowadays really adopt advanced algorithms, even AI, to a much greater level on top of data to deal with that. So let's look at that. What is a typical problem that we see within companies? We usually see that 90% of time of individuals dealing with data is wasted on sifting through very noisy data. It basically means look at every visualization on every dashboard, run good luck queries to see if you find something interesting. And it's kind of the needle in the haystack approach on data. And it's like, and again, we look at certain data and the quality is always good, and the quality is always good, and the quality is always good. We stop looking at that, and all of a sudden the quality is no longer good, right? And quite often we cannot deal with that through individual rules where we say, well, if the quality drops below 98.9%, send me an alert. Yeah, that works for a single KPI at a single level. But when we have hundreds of KPIs at potentially thousands of categories or countries or geographies around the world, we quickly have billions of combinations that we need to look at, right? Doesn't work. That means it's up to luck in many places to find these things. We sometimes dealt with changes in business models where a category in our products in Germany started to behave ever so slightly different than in Japan or than in the US. And we didn't see that in the macro numbers because the change at first was too insignificant to be identified. And by the time we saw it, it was too late. You know, a competitor had something different, had done something different in that market, and now it was really, really difficult to catch up or do something about it, right? And so dealing with that at scale, we started realizing we need to deploy algorithms, examples are signal detection, on all of our data so that we could actually point changes in data out to our individuals, to our analysts, to our specialists, where when they come in the morning, their inbox would say, hey, here are the top 3 things that algorithms have identified in the last 24 hours. You might want to look at that. And by the way, go give us a rating of how real that change was or how interesting that was, right? So that we can learn from that. And it's something that once we started doing that, it became really interesting. This became a solution all of a sudden for data quality at scale, because we used that also to identify where we had outliers in data, or where all of a sudden not enough data showed up or too much data showed up, because our signal detection algorithms would also identify that. So a change in data wasn't necessarily a business change out there. It sometimes was a breakdown of systems that we had that normally we would have totally missed. And sometimes we would have run with bad data for weeks or even months before somebody realized, oh, there's a problem there. So algorithms at scale are really an interesting thing. And it doesn't stop at algorithms. And nowadays, you hear a lot more executives around the world really starting to use the term of AI, artificial intelligence, bots, to say, how do we deploy them to help scale our business model to deal with the exponential increase in time to market, right? And how we have to push products faster and faster out there. And it takes algorithms to do that. When you do that at scale and when you wrap that into algorithmic apps, you can all of a sudden really build an environment where we can look at all data every day and identify what is changing in there, and identify when things are happening as they are happening, rather than have this needle in the haystack approach where we just poke into data, hopefully finding new insights. Here's a quote from one of the recent earnings calls from Amazon, where a CFO said, we're using software and algorithms to make decisions rather than people, which we think is more efficient and scales better. Think about that. If you have to deal with shipment centers and supply chain at a massive scale on a worldwide basis, you cannot rely on the fact that human beings identify what is needed. Amazon is really scaling out algorithms to increase their effectiveness, to even predict what the customers will be buying. This is what allows them to say, not only can we do all of a sudden one-day shipping, we can do same-day shipping. In certain markets in the US, they're now down to 1 hour shipping, right? Where you can buy a product and within 1 hour, it will be at your doorstep. You can only do that if you have the right products in a shipping location that is very, very close, obviously, to your customers. And if you can predict what these customers are buying, right? So algorithms are becoming a part of businesses. And whether that is in retail or in other organizations, it's something that's really happening. Another example I wanted to give you about algorithms here is something that we recently did at one of our internal hackathons. We run nowadays at Teradata quarterly hackathons where we invite employees from around the world, but also customers, to bring some of their most advanced data sets and give advanced teams a chance to find insights for them in that. In this particular case, we got a data set from our customers in Northern Europe, where they gave us access to their sensor data of deployed sensors on the ocean floor, where they're driving oil exploration and where they're drilling for oil. And one of the problems that they had is obviously breakage when you're dealing with oil leads to very, very bad things. At the minimum, it costs a lot of money. At the worst case, you create impact to the environment and a lot of other problems. And so their question was, we are listening to all of this data, we're listening to the rumblings of the earth. First of all, can we find in there when we break a drill bit down there below the ocean floor? More importantly, can we predict before it happens? Can we find leading indicators that tell us we are about to break something, therefore let's stop what we're doing right now, make an adjustment and deal with that? And sure enough, when you take that data and when you build algorithms, that's absolutely possible. You can absolutely see the underground caves that collapse just minutes before before the event, and it would save the environment, and it would save the companies millions of dollars to take that data in real time and make decisions of how to deal with that, right? It's something that if you look at various companies, to tell a customer how to fix something after it broke is easy. Telling them something before, that's usually the magic, where the money is being saved, right? And you see that kind of pattern and behavior, of course, in more and more companies. And we see predictive maintenance. We see we employ this ourselves, or deploy that against software development. How can we identify software defects before they come out to customers? How can we do predictive maintenance on big data systems at scale, right? It's all about algorithms at scale and implementing them so that we can feed information to human beings within companies. If we take this all the way back to the example where we started with the CFO dealing with a problem, applying the concepts as to the Sentient Enterprise, we said before, the CFO all of a sudden realized there's a 5% drop in revenue, right? Everybody was up in arms. Nobody really understood what it was. There was speculation going around. Usually companies give in and just say, well, I guess it's just the way it is, right? If you take a look at that, what usually happens is something started at some point in time, and then it creates an ever-growing snowball effect that ultimately we find in our data, and we identify, and then it's usually too late to do something, because something that started 5 quarters ago is well underway. And when that is the case, it's very hard to react to that. What we're doing with the Sentient Enterprise is really something to say, let's go back to the problem when it happened, right? How can we detect something through algorithms at the point in time when it's happening? And how can we deploy these stages and these capabilities of the Sentient Enterprise through, okay, an algorithm just identified an outlier in data. How can we now assemble an agile team to deal with that and identify what is really going on in there? How can we use collaboration within the organization to find out, is somebody else seeing the same problem? Here are some theories, right? How can we collaborate and work together on dealing with that? Ultimately to saying, I want to codify up an application that identifies this kind of problem, because if I can identify the problem and deal with it, in this particular case, there was a new pricing plan introduced by a competitor, a new phone model that got rolled out that simply changed customers' behavior, plus an outage that we had during winter where some of our switches were blown over by a blizzard. If we knew back then that this will create a runaway thing, we could have done campaigns, we could have done something right there to change the problem. And if we apply these capabilities, what we are seeing is that the earlier we detect a change in a company, the earlier we detect that something is going wrong, obviously, the better we can react, right? And when you look at quality of automobile, in the automobile industry, it's a big problem, right? Every month that you can detect a quality problem earlier saves usually millions of dollars in the long run, because if you can avoid large recalls, that's a big deal for companies. Now, most companies just simply take too long to deal with that in real time, or they're only good in one department at doing that. When we talk about the Sentient Enterprise, it's really about how do we create an organization that scales across business departments, where data is being leveraged and analyzed, where we understand what people are doing with data, where we deploy concepts like analytics on analytics. We can understand what other departments are doing, so that we can, as a company, learn and react faster to the changes of data. Thank you very much for joining me on top of Munich in this wonderful location.